Section 17.2 deals with the question of whether or not precipitates will form. And that's what this says. A solution is prepared by dissolving 1.8 grams of calcium fluoride in water to make 210 milliliters of solution. Will a precipitate form? Well, you want to go about it the same way. You want to write down what you're given in terms of an equation. Calcium fluoride solid is going to break apart into calcium ions and fluoride ions, both of which are aqueous. Got to balance it there. The only difference is we don't know if we're at equilibrium or not. So just like last chapter, you need to solve for Q and compare that to KSP. So you're going to write your Q expression, which is done the exact same way as an equilibrium expression. Concentration of Ca2 plus times concentration of F minus squared. Once you solve for Q, you can just compare that with your K value, and depending on what that is, we'll determine whether it shifts right or left. So let's figure out what our Q is here. All I'm given is the grams of calcium fluoride and the milliliters of solution. And we know that we need concentrations. Well, concentrations are molarities. So what I first need to do is find the molarity of my calcium fluoride. So molarity, we know, is moles over liters. So I'm going to need to change my grams into moles. 1.8 grams of CaF2, if I turn that into moles, from the chart, calcium is 40.1. I've got two fluorines at 19 apiece. Turns out to be 78.1 grams per mole. When you divide that, I have 0.023 moles of CaF2. To find the concentration, you have to take whatever your moles are and divide it by your liters. So once you have the moles, 0.023, you simply need to take that and divide it by the 0.210 liters. 210 milliliters we know is 0.21 liters. When you divide those numbers, you get a concentration, the molarity, to be 0.1097 molar. And that is the concentration of calcium fluoride. Well, how does this work? If I know the concentration of calcium fluoride is 0.1097, then I also know the concentration of calcium is 0.1097 because it's a 1-to-1 ratio. Every one calcium fluoride will give me one calcium. How do you get the fluoride concentration? Well, every one calcium gives me 2 fluoride. So you just have to double your calcium. 0.1097 doubled is 0.2195. What do you have to do with that number? You have to square it, because that's what the equation right here says to do. It says take whatever your calcium is times the fluoride and square it. When you multiply that all together, I believe you get 5.3 times 10 to the negative 3 for the Q value. If we look up here, they tell us that the K value is 4 times 10 to the negative 11. Well, how does Q compare to K? Negative 3 is bigger than negative 11, so Q is larger than KSP. If the Q is larger, it's going to have to become smaller by making more reactants. So what's going to happen is it's going to shift to the left, and if it shifts left, we are making a solid. So will it precipitate? The answer is yes. And the reason is because your Q is greater than KSP, so it needs to shift left and make that solid. Let's try one more example here. Same thing, just a different substance. In this case, I have lead sulfate. So PbSO4 solid is in equilibrium with lead ions, Pb2+, and sulfate, SO4 2-, both of which are aqueous. I want to find out whether or not a precipitate will form. So what I need to do is find Q and compare it to this KSP. So my Q expression is simply concentration of Pb2+ times the concentration of SO4 2-. Again, concentrations are molarity. So what I really want to do is find the molarity of the substances. What I'm given is moles of lead sulfate and milliliters of water. Well, to find the molarity, this was nice. In this case, they already gave me the moles, 5.4 times 10 to the negative 7 moles. If I divide that by my liters, which is 0.470 liters, I get a concentration of 1.15 times 10 to the negative 6 molar, and that's the concentration of the lead sulfate. Well, if I know what lead sulfate is, I also know what lead is, because for every 1 lead sulfate, I get 1 lead, and for every 1 lead, I get 1 sulfate, which is also 1.15 times 10 to the negative 6. So when you multiply those together, you end up getting a Q value of 1.32 times 10 to the negative 12. Our KSP was 1.3 times 10 to the negative 8. So in this case, Q is less than KSP, which means it's going to have to shift to the right. So does it form more solid? No, it will not form a precipitate. It actually forms more ions.